Imagine a world where a tiny change can have a massive impact. A place where the predictable and the unpredictable dance in a cosmic ballet. For many years, we believed the universe to be like a game of billiards, with each ball moving in a predictable path, each cause creating a specific effect. However, a gentleman named Edward Lorenz began to challenge this notion in the 1960s as he delved into the intricate study of weather patterns using a complex computer program. Lorenz made a seemingly insignificant change, rounding a number in his code by a tiny fraction. It was nothing more than a speck in the vast sea of calculations, but this minor alteration, this single decimal point variation, didn't just ripple through his computer program. The weather patterns he'd been studying, once predictable and orderly, suddenly became wildly erratic, twisting and turning in ways he'd never foreseen. It was as if he'd unlocked a door to a whole new world, a world where the tiniest of changes could trigger the greatest of storms. Lorenz had stumbled upon a hidden truth. Tiny changes in initial conditions can lead to drastically different outcomes. This wasn't just about weather patterns anymore. This was about every complex system we know. The stock market, human psychology, even the intricate dance of galaxies across the cosmos. All bound by the same fundamental principle of unpredictability, all echoing the same chaotic whisper of Lorenz's discovery. This concept became known as the butterfly effect, a captivating notion that suggests a minuscule flutter of a butterfly's wings, a seemingly insignificant shift in the atmosphere, could set off a spiraling chain of events leading to a colossal storm half a world away. It's a poetic image, isn't it? But what does it truly mean? The butterfly effect is a shining example of how small changes in initial conditions can lead to dramatically different outcomes. It's a key concept in chaos theory, and it challenges our traditional understanding of cause and effect. This principle is not just confined to meteorological phenomena. It extends to other complex systems too, such as the stock market, population dynamics, our bodies, and even the intricate dance of life itself. Is the butterfly effect an exaggeration? Perhaps. But it serves as a powerful metaphor, a cautionary tale that underscores the inherent unpredictability and limitations of forecasting in complex systems, like weather, the stock market, or even life itself. Imagine a pebble dropped in a pond. The initial splash is small, but the ripples generated by that one action spread far and wide, reaching every corner of the water's surface. This is much like the ripple effect in chaos theory. A seemingly insignificant event can set off a chain reaction of events, leading to major, unpredictable changes in a system. But here's the twist. Chaos does not mean randomness. It's not a free-for-all where anything can happen at any time. No. Each ripple in our pond follows a specific path dictated by the physics of water. Each event in a chaotic system is the result of definite, albeit complex, processes. So when we speak of chaos theory, we're not talking about a universe devoid of rules. Rather, we're talking about a universe where the rules can be so intricate and intertwined that making long-term predictions becomes a Herculean task. Chaos theory doesn't mean the universe is random. There are still underlying rules, but they can be so complex that long-term predictions become impossible. Chaos theory may seem unsettling, but it also holds a strange beauty. It paints a picture of a universe in which nothing exists in isolation, where even the smallest occurrences can ripple out to influence grand events. It encourages us to appreciate the significance of each moment, each action, each creature, no matter how seemingly insignificant. So the next time you see a butterfly fluttering by, remember, it might just be a tiny player in a vast and unpredictable symphony.